Welcome to Ask and Learn.
For this problem, we've been given a function v in two variables, x and y. And our goal for this problem is to sketch some equipotential curves, which is another way of saying we're looking for level curves. We want to know where this function, we're going to let this function equal a constant and what's happening at that constant. If you change what k is, you can get some different glimpses of what's happening with our function at different points. Okay, so let's see what's happening with this function. I'm just going to leave it in terms of k for the moment, just so we can see this generic case. Now, this one is just going to really truly be a sketch because everything here is variables. I've got r's and c's and x's and k's and y's. But I want to see what kind of lines. Are these straight lines? Are they circles? Are they ellipses? What's going on here? So first of all, I have a square root, which I want to get rid of. So I'm going to just square everything. That gives me c squared on top. My denominator is what's under the radical, equaling k squared. Okay. Now I'm going to cross multiply. Okay, and I think I want to put that x and y kind of by themselves. So I'm going to divide both sides by k squared. Minus x squared minus y squared. Now, since both x and y are negative, I like it when they're positive, at least one of them to be positive. So I'm going to multiply everything by -1. I want to have my x and y positive. And again, partly that's just me, but for me, I find it easier to see what's going on if I make them positive, if at all possible. So that gives me -c squared over k squared equals -r squared plus x squared plus y squared. Okay, so what kind of equation has both x squared and y squared where they're both positive and they both have the same coefficient? This is a circle. So let's put this kind of in our standard circle form. I'm going to have x squared plus y squared on the one side. I'm going to move that r squared over. So there is our circle. It's centered at the origin because I'm not adding or subtracting anything to those x squareds. And this is my radius squared. Okay. Now this is, depending on what we let r and c and k be, this could be a bigger or a smaller circle. We don't really know yet. But you can see as if I leave everything else the same and just change the k, that will change my radius because I'll be subtracting something that's either larger or smaller from my r squared. So if I was going to graph this, this would be concentric circles centered around the origin.